Hi everyone, this is Vivek. Welcome to my Vivek A to Z Chemistry YouTube channel. I have already uploaded hybridization concept trick number 1 in my YouTube channel. To get a link, see the description box. In this video, we are going to discuss about hybridization concept trick number 2. The structure of molecule can be predicted on the basis of hybridization. In here, the general formula n is equal to of inside the square bracket V, M, C and A. So V stands for numbers of electrons in valence shell, plus M stands for numbers of monovalent atoms, minus C stands for charge for cation and A stands for charge of anions. Here, what is n? The value of n, if you are getting 2, the hybridizations we can say that Sp. If the value of n is 3, then the hybridization is Sp2, 4 Sp3, 5 Sp3d and 6 Sp3d2, 7 Sp3d3. So by using this data, we can identify the hybridization concept easily. Let's move on to the next one. Here you can see the 6 different types of hybridization. Type 1. In type 1, the central atom is surrounded by monovalent atoms only. In type 2, the central atom is surrounded by divalent atoms. In type 3, the central atoms is surrounded by both monovalent as well as divalent. In type 4, the hybridization in cations. Type 5, hybridization in anions. Type 6, hybridizations in complex ions. Let's see one by one. Let's move on to the next one. The first one, that is a type 1. Central atoms is surrounded by monovalent atoms only. And here, which one is the central atoms? We have to know. For example, consider this example, this one, phosphorus pentachloride. Okay, here in phosphorus pentachloride, you can see that the phosphorus is a non-metal. And the atomic number of phosphorus is 15. So here 2, 8, 5, that is the electronic configuration. And here so we have to substitute the value, that is the valency electrons for V. Okay, so that is the central atom. P is the central atom here. So V, that is 5 plus M, and check out the M. Here the monovalent, M stands for monovalent. Here how many numbers of monovalent? That is 5. So you have to write 5. So is there is any cation? No. So just to write 0. And plus O. O means what? That is, sorry, here A. A stands for, that is anion. So that is 0. So total 10 by 2. So just cross and we will get that 5. So 5 means the hybridization Sp3 dehybridization. Okay, so Sp3 dehybridization. By using the same trick, we can go for the next molecule, that is H2O. So here the central atom is oxygen. So atomic number for oxygen, that is 8. 2, 5, and you can say that 6. Okay, so 2, 6. So here how many surrounding atoms? 2 surrounding atoms. Just enter all the data. So of V is 6, numbers of surrounding monovalent atoms, that is 2. There is no cation as well as anion, so just enter here 0 and write 0. So that is 8 divided by 2 and you will get that 4. So 4 means that is Sp3 hybridization. So let's move to the next molecule. here you can see that the phosphorus pentafluoride. So P stands for phosphorus. The atomic number is 15. Electronic configuration of a phosphorus is 2, 8, 5. Okay. So here we have to write the valency of the phosphorus is 5 plus monovalent is also 5. There is no cation as well as anion. Just write 0, 0 and you will get that 10 divided by 2. You will get n value is 5. So 5 means that is sp3 dehybridization. So let's move to the next one. Here ClF3, that is Cl. Cl means chlorine, that is the central atom. So you can see the structure, and here the atomic number of chlorine is 17, 2, 8, 7. So the outermost electron is 7. So 7 plus monovalent is 3, and there is no cation as well as anion. So 10 divided by 2, you will get again 5. So the same hybridization, that is sp3 dehybridization. Okay, let's move to the next one. Here sulfur hexafluoride, that is of sulfur, we know that is 16, 2, 8, 6, and the the outermost electron is 6. Just write 6 plus m. M is numbers of monovalent. Here 6 monovalent. There is no cation as well as anion. And here 12 divided by 2, we will get that 6. 6 means the hybridization is sp3 d2 hybridization. Okay. So let's move to the next one. Just a minute. Let's move to the next one. So here that is a type 2. Central atom is surrounded by divalent atoms only. So here the divalent is oxygen and sulfur also given. Okay, these all central atoms. So here let's move to the first one, that is the sulfur dioxide, and here you can see that 1 by 2. V stands for, that is central atom is sulfur. We know that atomic number is 16. The electronic configurations of sulfur is 2, 8, 6. The outermost electron is 6. So 6 plus monovalent, there is no monovalent, and here there is no cation as well as anion. So just write all 0. Okay, so 6 by 2, you will get that 3. So 3 means the hybridization is yes, sp2 hybridization. Okay, so let's move to the next one, carbon dioxide, and here the carbon atomic number is 6. So 2, 4. Okay, so of the outermost electron is 4, and there is no monovalent as well as cation as well as anion. So 4 by 2, that is you will get that 2. So the hybridization is sp hybridization. Let's move to the next one, and here this one is xenon trioxide. So of, we know that xenon, the outermost electron is 8. Okay, because it is a noble gas. So 8 plus, there is no monovalent as well as there is no cation and no anion. So just write all zeros. So 8 divided by 2, you will get that 4. 4 means that is hybridization is sp3 hybridization. So you can identify the hybridizations very easily. These are all comes under type 2. Let's move to the next one, type 3. Here the central atom is surrounded by monovalent as well as divalent. Let's move to the first examples. Here POCl3, and here that is a phosphorus. So we know that the atomic number of phosphorus is 15, 2 comma 8 comma 5. The outermost electron of phosphorus is 5. Okay, so of inside the brackets V is there. V means that is number of valency electrons present in the central atoms. So here the central atoms is P. P stands for phosphorus. So here the valency is 5. There is monovalent is there. 3 numbers of monovalent, that is 3. No cation, no anion. Okay, so total 8 divided by 2, and here you will get that 4. 4 means the hybridization is sp3 hybridization. So let's move to the next one. Here xenon difluoride. Okay, xenon difluoride. So already we discussed xenon is a noble gases. So it comes under noble gas. Outermost electron is 8. Okay, so 1 by 2, 8. There is 2 monovalent, that is a fluorine. So minus cation, that is 0, plus anion 0. So total 10 divided by 2, we are getting that 5. So 5 means the hybridization is sp3 dehybridization. Very simple. Okay, let's move to the next one. Type 4. Here hybridizations in cations. So far we discussed that the molecules, and here you can see that NH4 plus, that is ammonium ion. So the central atom is nitrogen. So nitrogen, we know that atomic number is 7. The electronic configuration of nitrogen is 2 comma 5. Okay, so of that is V value is 5. There is a monovalent, that is a 4 number. Yes, cation is present, so minus 1. No anion, so 0. So total 1 by 2, that is 9 minus 1. We will get that 8 by 2. 8 by 2 means that is 4. 4 means we have to say that the hybridization is sp3 hybridization. Let's move to the next one, that is a H3O plus. So here the central atom is oxygen, so that is atomic number is 8, so 2 comma 6, and the electronic configuration is 2 comma 6. The outermost electron is 6. So of just a minute, here and here, that is here of, so outermost electron 6 plus monovalent is 3. So cation, that is 1, that is no anion, just write 0. So here 1 by 2, that is 9 minus 1. So here 8 by 2, 8 by 2 means we will get that 4, that is sp3 hybridization. Okay, let's move to the next one. This is a cation. Okay, methyl, okay, methyl radicals. Here that is methyl cation. So here plus. So here 1 by 2. Here we know that the carbon is 6, 2 comma 4, and 4 means that is a valency electron. So plus hydrogen is 3 numbers, there is a cation 1, so no anion, just write. So 7 minus 1, 6 divided by 2, we will get that 3. So 3 means that is sp2 hybridization. sp2 hybridization. Okay, very simple concept. Let's move to the next one. And here hybridizations in anion. So last one we discussed that cation. So here we are going to discuss about the anions. So first we have to find out the central atoms. For first molecule, so you can see that the pictures, sulfur is the central atom. We know that the atomic number of sulfur is 16. So 2 comma 8 comma 6. The outermost electron is 6. So of 6 there is no monovalent, minus cation, there is no cation, anions are there, so anions, that is minus 2, so we have to write it here 2 only. So total 8 divided by 2, we will get that 4. So 4 means that is sp3 hybridization. Okay. So let's move to the next one. So here chlorine is the central atom. So here we know that atomic number is 17. So 2, 8, 7 electronic configuration. The outermost electron is 7. So of 7, okay, there is no monovalent, so 0, there is no cations, so 0, anion is 1. Okay, so 8 divided by 2, we will get that 4. So 4 means again we are getting the same hybridization, so sp3 hybridization. Okay, very simple. Let's move to the next one, that is type 6 hybridization in complex ions. And here you can see the first molecules, that is I3 minus. So you can represent this one as I2 minus. Likewise also, look at the picture ICl4 minus. So here you can see that the central atom is iodine. We know that the outermost electron for a halogen is 7. Okay, 7 electron is the outermost electron. So we can apply the values. So that is V stands for, that is central atom outermost electrons. Okay, so 7. Check whether monovalent is there or not. So it's there. So how many? There are 4. So 4. Cation, no cation. Anion, yes, anion is there. So just 1. So total 1 by 2. And here 11 minus 11 plus 1, 12. So 12 divided by 2, how much? We are getting that is 6. So 6 means that is sp3 d2 hybridization. sp3 d2 hybridization. The last here, that is 1 by 2, and here the central atom 17, 2, 8, 7. So the outermost electron is 7. Just enter the V value here, 7. There is 2 monovalent and there is no cation, only anions are there, that is 1. So here 9, 9 plus 1, 10. 10 divided by 2, we are getting that 5. So 5, that is sp3 dehybridization. Okay, we completed all the types of hybridization. Okay, so I hope you understood all. So this is for you. And dear students, please subscribe and support my channel to get more videos related to your competitive exam. Thank you. We will meet in the next videos. Thank you all.